This is from section 6.2. So this is the normal distribution applications. So what is given is the mean lifetime. So I'll write down the variable is lifetime, right? The mean lifetime is 14 years. I'll be using the parameter notation. And the standard deviation, so I'll be using the corresponding notation, 1.75 years. Because this implies the population. So we're talking about parameters over here. Okay. Identify the individual variable and type of variable in the context of this problem. So the individual object is, if you look at all the possible answers you can choose from, and you have many options, the best one of this one will be a randomly selected dishwasher, right? For this makes sense, for this is an individual object that we collect information from. The variable information collected from each individual, in other words, what do we collect from each individual? Well, what we collect from each individual is the lifetime. Okay, this is what we collect. This is the variable lifetime in years. This variable lifetime is, and the options we have here, of course, it's a quantitative and it is continuous, right? It's a quantitative, it's a measurement, and it is a continuous, it's time. What is the wording of the random variable x in the context of this problem? So in the context of this problem, the random variable x is the lifetime of a randomly selected dishwasher. So again, I would strongly encourage you to use the language, statistical language, and to be very specific. This is how the questions look like in the exam. And if it's an open-ended question, if you need to actually write it down, I need to see all of the keywords and all of the specifics in order to be able to give you full credit. I need to see that. Okay, why can the empirical rule be used to approximate probabilities of this problem? I have to think back of when can we use the empirical rule. And out of these options, you can say the empirical rule can be used to approximate probabilities for any problem where there is quantitative random variable. No, it's not going to be used for any problem with that. It's going to be used to approximate probability for problems where there is a random variable that has a normal distribution. And we can assume the random variable has a normal distribution, or actually it is given in the problem. So it's not this one. So it should be the last one. It is given in the problem that the random variable has a normal distribution. It says right here, lifetime is normally distributed. And now let's use the empirical rule. In order to use the empirical rule, and this is D, okay, in order to answer D, we have to recall the empirical rule. The empirical rule, and I'll write it down here just to make sure you remember this, is also called the 68, 95, 99.7% rule. Why? Because it gives us the percentage of data that is located within 1 standard deviation of the mean, 2 standard deviations of the mean, 3 standard deviations of the mean. So this is the basic empirical rule. So the first thing you do, you need to find the values that are located 1, 2, and 3 standard deviations from the mean. So here is where this information is actually the key for this problem. The mean will be 14, And we use the standard deviation to figure out the values located 1, 2, and 3 standard deviations above the mean, 1, 2, and 3 standard deviations below the mean. Okay, so how do we use that? We simply add 1.75 to 14 once, and that will give us 15.75. That value is located 1 standard deviation above the mean. Now 15.75 plus 1.75, it will give us the value located, and I will use the calculator for that. 17.50. This value is located 2 standard deviations from the mean. And if I keep adding 1.75, I'll get 19.75. This value is located 3 standard deviations from the mean. Okay? If I move backwards, I'll simply subtract from 14 the 1.75, and I get 12.25. This value is located 1 standard deviation below the mean. Keep subtracting 1.75. That gives me 10.5. This is another standard deviations from this and 2 standard deviations from the mean. And subtracting one more time, 1.75, and get 8.75. Okay, so these values are located 1, 2, and 3 standard deviations below and above the mean. And the empirical rule tells us that between these two values, so within 1 standard deviations from the mean right here, I expect to see 68% of the data. Now, 2 standard deviations from the mean, I will have 95% of the data. And 3 standard deviations of the mean, and that will be almost everything, right? That's 99.7%. It's very, very close to 100. Okay. So, how do we apply the empirical rule to answer this question? Well, they ask us specifically, what is the percentage of dishwasher that lasts between 8.75 and 19.25? So let's just locate 8.75. Here is 8.75. This value is located 3 standard deviations below the mean, right? And 19.25, I believe this is supposed to be 19.25. There is a typo. That's supposed to be 19.25. I will add again just to make sure. Yes. So that's supposed to be 2. And between this value. So I'm wondering what percentage of the values are within 3 standard deviations. Now this happens to be, this is the middle, 3 standard deviations above the mean. This is 3 standard deviations below the mean. To answer the question, I don't really have to do any other math, but just look at the answer right here. Chebyshev theorem tells us that 99.7% of the data is located within 3 standard deviations of the mean. Which means this is the answer right here, 99.7. Okay. Now this happens to ask for 3 standard deviations below, 3 standard deviations above. Okay. Now if they ask you for 1 standard deviation below and 3 above, you'll simply have to figure out each piece under the normal curve. Each one of these areas, well, actually you have this information in the textbook and in the resources, and just add those pieces corresponding to the data on the horizontal axis. Okay. Now,